officially. And there we go.
Okay, so today is the first of three of our meetings in which we're investigating using AI to create some documentation and some examples for the Propeller 2. This came up at our last Propeller Live forum if you watched the recording, and yesterday Chip and I got to see a preview of what Steven's going to show us today. So we're looking for him to share this and then get some feedback from everybody here on what would make this useful to you. How do you see this shaking out? I think my objective is to make it easier for people to start writing code for the Propeller 2 so that we have a wider audience. But we'll be interested in what everybody has to say.
So,
And by the way, before you start, Stephen, if you signed up for one, you signed up for all three of these, I believe. So you'll get notices.
That's correct.
Okay, carry away.
okay, it looks like sharing has not been turned on.
Sharing was never turned off.
It's certainly not allowing it now.
Let's see. Let's see, advanced sharing options.
All presenters.
There we go. They must have changed the default.
In that normal.
There you go.
All right. Let's see what we have here as I get this set up. Okay, that's better. So first of all, let me see if I can see people. Before I actually bring this up, how many of you have played with AI at all so far?
Been a little bit.
So you have some basic understanding of how it's going to work then. Just a little bit. I'm seeing that mentioned. Yes. Okay.
Yeah,
that's
just
perfect.
a little bit. You ask it a question, then you got to clarify it. Tell it, I don't want C language. I want propeller chip, blah, blah, blah. You got to tell it exactly what you want.
Yeah. Exactly. Okay. So let me just start with some basics. And I went out to ask of one of my favorite research sites. I'm not advocating for any of these sites, please. This is just my experiences that I'm going to talk to, and everybody's mileage may vary with this kind of stuff. So what is an AI? It's basically, you can see the description here. Computers and machines are designed to act like humans, learning and solving problems. They have language models, tend to think like people, are used to recognize faces, photos, understanding spoken words, all of this, okay? And then here's the large language models explained. So I put this here so we'd have it available and can get a sense of what we mean by this. Moving on then, how then do we describe what's an AI chip and what does it mean? And so I'm just going to give us just 2 or 3 minutes of this stuff and then we'll move on. But basically, these are chips dedicated to processing networks that are especially accelerated and high parallelism. So I'm putting this here so it'll be in the video so you have it. And then benefits. And lots of companies how are they different? How are these AI chips different from graphics accelerators? So here's a little bit of reading, right? They're custom built for tasks like learning, reasoning, and processing enormous amounts of data in parallel. GPUs are somewhat good at this, but there's additional enhancements to make the AI chips beneficial. So again, one of the places I like to go, give me research, tell me about this. And then who are the dominant key makers of AI chips? And so here you've seen these players in the news. Who's doing it, why? And I'm an Apple user, avid Apple user, and so I tend to pay attention when I see things like this. Yeah, we've known about that. Apple's had neural nets now for 8 years in their chips. And so if you see me looking to my left, it's because that's where your videos are. So I have all of you over there, not on my main window. Okay, so that's pretty much all I wanted to say here. Now, one of the things that we do a lot is we work with chat in Windows, and on our phone, in our browsers, and that's quite different than what I'm going to talk about today. And what I want to do is make sure that you have a sense. Then I go to absolutely the wrong location, so I can't give you a sense. What I'm going to talk about today is what is Claude Code. And this is their marketing speak, not mine. But Claude Code is a different animal. And that's this one right here. And why I say it's a different animal is I tend to use this as in terminal mode. And so I install a local app on my Mac, on my Raspberry Pi or whatever, or my Windows machine, and then I interact with it by typing. And I will show you what I mean by that in a second, but Claude Code is what we're talking about here. And this gives you an ability to download it and use it here. And they're delivering it in many different ways. But the important part that I want to talk to is that this is a command line tool and it's interactive. So now I'm going to start our little command line tool. And so I'm here and there's nothing in the directory. And so I'm going to start Claude, and what it looks like when I've started is this. And when I first get into a project where I'm going to work with something, I'm going to do an init. And the point of the init is this creates Claude MD, where it's going to remember key facts about the type of work that you're doing, the project you're working on, and things like this. And so it's out here studying. And so I'm just going to give you a tiny bit of how do I set it up, and then I'm going to go into some cautions. All right. And you notice it's prompting for permissions to interact with the directory, and it's prompting for permissions to interact with where you can write files. All of this is quite important. And that's going to have to do with some of the things I want to talk about here shortly. But what it's doing is it's creating this initial piece of information that remembers what it's doing. It's taking a little bit of time. Thank you, big fast machine. Once you're set up, you can decorate key understanding in this file, and it will always remember it every time you come back for different sessions. So this is the command line tool. And if it'll come back to me, I can actually do some more demonstrations. Another thing I use is something called whisper flow. Windows users don't need whisper flow. Windows has automatic voice recognition and can do voice transcription for you automatically. There's a way to configure that. I work on Macs, and so I use voice transcription let me move the videos in front of me so it looks like I'm looking at you guys. I use voice transcription now because it's just easier to sit there and talk to Claude than it is to type. Just to give you a sense, my speaking rate is about 150 words a minute when I'm interested, and my typing is much slower than that. And so I can actually speak to Claude and get it to do things quite rapidly when I want to. And I use Whisper Flow for that voice transcription. That's a downloadable app. It's a paid app on Macs. For this purpose, I didn't mind paying it. It's a small fee. Okay, are we back yet? Yes, we're back. Okay, what are we doing? How does it know all this? It's kind of intriguing that it knows all this. Okay. So it's looked around my environment and figured out some things. And it also knows I have my compiler, Peanut TS. It also knows I have load P2, things like this. And so we can find some of the tools that it might be interested in using. But to give you a sense, can you tell me about how you can help me work on code? And so you see, the way WhisperFlow works is I held down a key, I talked, and then I just pressed the return key, and now I get this kind of information back from Claude. What languages do you natively know how to work in? And so I'm asking it questions. Claude has two models, Opus, which is like 10 times the rate if you're spending for Claude, and then Sonnet. And Sonnet is kind of a master of code generation, and Opus is more in natural language and writing documentation. And so, oh, it's been learning. Okay. I wonder how much cross-pollination we've got here. But you can see what's really happening. And so I can ask it to describe things. One of the things that we've had problems with up to this point is these languages are commonly available to the training sessions for AI models. These languages and PASM are not commonly available yet for models. And so what I'm trying to work on is making it available in a form that Claude can actually use it. And so I want to do two things real quickly. Number one is this is the new repository available. And just so you can see it, there's the URL in chat, so you have it. The point of this is a couple-fold. This is a system that we can point Claude to now and have it understand an awful lot about the P2. But before you go anywhere with this, I need you to understand something really important. So I created this using Claude. All right. So this is downloadable now from this website, and we really have to pay attention to this. So privacy guide. You're using external cloud-based systems to process your data. So you absolutely need to understand what risk that is if you're working on things that are proprietary and not open source. If you're working under contract, you have to get approval from whoever hired you to use these kind of tools, because whatever you're working on can be seen, albeit temporarily in many cases, by those servers. So we have to understand. So I wrote this specifically for Claude Code. And welcome, we're going to try and use this for Propeller 2 with Claude Code as your AI partner. One of the things we find strong in code development is to have two of us coders sitting side by side. We bring different knowledges to the problem solution. And in debugging and in building live code, our combined experience is generally stronger. That's absolutely true here with the AI too, as long as you're careful in how you use it. And so this is paired coding, but with an AI assistant is effectively how you're thinking about working. So understanding Claude Code in your workflow, it's an assistant that's going to help you. And it's going to help you with Spin2 and PASM and understanding areas of the architecture with P2 that you haven't played with before. If you haven't played with executing code out of the LUT or executing code out of HubRAM, or you haven't played with the streamers, or you haven't played with LUT sharing between cogs, or you have different smart pin modes you haven't played with, it can help you learn about how to use those modes. And that's what we're going to try and do and make sure all the information is rich. So what Claude Code isn't, it's not a data collector, it's not a telemetry system, right? It's not connected to other users. It's between you and the cloud services at Anthropic. And it's not permanent storage. There are some opportunities coming up to participate in things, so I have to warn you of that. Code privacy, session isolation, sessions are independent, training on your data, you choose the defaults. Claude has an opt-in policy now where you can choose to help improve Claude, and the conversation and things will have a retention life of somewhere around 5 years while they use the conversations to improve the models and understanding of code and things like this. That's an opt-in policy. You need to understand that. Your decision, proprietary protection, and open source. If you're working in proprietary things, copyright protected and things like this, then this probably isn't the environment for you. Or you have to take special precautions to use it in regions of the application where you can. Temporary processing only. It's only processed during sessions and not communicated between sessions. So best practices. If you have files that you put out there that have project keys in there, wipe out the keys. Don't let Claude see the keys. Okay, pretty simple. Same thing with version control. Never put these keys in version control. It's a bad idea. Okay, that's public versions. Abstract proprietary logic. It just gives you examples for how you need to filter out things that are proprietary to you if you're going to work with it. Use generic examples, ask for the AI assistant's help, and then you can continue working. Smart strategies. Compartmentalize your queries, right? So safe versus risky gives you some examples. And so this document is available to all of us for reference. We have to be real careful with this material if we're working on proprietary things. Working on confidential projects, air gapping is always one of the keys for deep confidential. Means no network connect, nothing, right? And then abstraction method. Create stubs, hide the sense, don't let the sensitive components be seen at all. You can create the APIs to them, and then you can talk to them. Data security, environment, and project planning. And then safe sharing practices. And thank you for cutting me off. Show me the rest of the pages, please. All right, code review checklist, after development, how to clean up afterwards, technical limitations. Now, this is important. And this is where you have to be careful. One of the things that most of us do who have been around these models for a while, who work in the command line environment, we're very careful to work in a containered environment where all they have access to, no matter what, is whatever's in the container. If you work local on your host, it generally does have protection to stay within your folder tree that you're working in. So when you have a top level folder, it's going to stay in here and folders below. And so you're generally safe there. But stay protected. There are ways to turn off protections of what this system can use, gain access to. Like, does it need to inform you when it runs a command it's never run before? Does it need to inform you when it's going to write to new files? Does it need to inform you when it's reading, when it's using a different tool that it hasn't used before? By default, it has to. And that's the way you protect yourself. When you're running in container, you can turn off some of those protections, and now you don't have those breaks in workflow because you're not worried about risking. Typically, a container is completely version controlled. And so I will have all the contents under version control. When I turn it loose to work on a project, I can open up the gates to let it do what it wants to, because I know that any changes it makes, I can recover from, either by recalling from the Git repo or by then wiping out the changes and starting over if I need to. If you're not careful, you can ask it to do something where it can wipe out your local files. And so you kind of have to be pretty careful to not do that. It's, so these are the warnings. What Anthropic can see, okay, about general things, what Anthropic cannot use by default, what remains private, even with opt-in, okay, So again, I tried to put this all together so we all would have a reference to what's safe and what's not safe to do. And so it's all here. Does Collide learn from bugs? What happens by code after conversation? It's all here. And then if you're working with a company, then there, what's quick reference card? What's safe to share? Never share. Okay. Don't share API keys, customer names of data, proprietary algorithms, patent pending, company trade secrets, blah, 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 blah. Just don't do it. Okay. Sanitize first. If you're going to let it see some of this code, remove these things from the code before you let it see it, if you have to protect it. I generally work on open source. And so I'm planning on turning everything open anyway to the public. So I don't generally feel the need to be concerned with these issues. Your cases are going to be different. And so think through your case clearly and decide where you can use this. And then let's go to happy coding. Now that we have tools we can use, we understand the restrictions just like most tools. Let's go out and enjoy that. So that's really what I wanted to show you from this. Now we can get on with doing other things. So back to this. Before I go anywhere now, do we have any questions so far that I can answer? I wanted to make sure that was in front of us because we have to be careful with company secrets. What else do you have questions, Vice? No questions. Anything in chat? No. Okay. Are we all just happy to go on then?
Wait. Sorry. You're,
Okay.
did I unmute myself? Okay, I couldn't find my
You did.
unmute. Okay, sorry to disturb real quick. Okay, I'm looking at the screen right now. Okay, I have your GitHub thing open up. Am I able to follow this on your GitHub thing someplace or in Claude? Do I have to go into Claude?
Actually, you can follow me in Claude in this green and black window. I'll be demonstrating there. But in the repo, and what I'm going to show you now is how I use the repo to connect up this Claude to then start asking P2 types of things. And that's where we're going next. And so I'll show you, and then you'll have the repo immediately so you can do this yourself.
Okay, I'll just wait to do it later. Then I'll just follow along. Okay, I can watch this later. Thank you.
Sounds great. Any other questions? Okay, I'm going to drag you guys off to here. I'm going to bring this back. All right. All right. The question is where, okay. See this link right here, Claude Code Quick Start. This one's the what you want to do here. So I'm going to skip this first part because we're going to talk about this next, but I'm going to go right to here. So you see what it says, please add the following to Claude, but that's actually talking to Claude. So I'm going to hit this copy button right here. And then I'm going to move this aside and I'm going to say, hey, Claude, with a paste. I'm going to say this. You notice that we said, please add the following to Claude MD. Claude MD is something that every time you start Claude is reread. Every time you start Claude in a given project file, it's reread. And so it's kind of a way of carrying this context forward. Every time you get back into this project, it's going to know these connections. Okay, so there it says added the P2 knowledge base access. And see, it contains warnings in here. It says, here's the repository, here's where the raw files are. Start with this file initially to learn where things are, but then use the manifest files to discover. Do not clone the repository. That's a way to do this. You can run everything locally, doesn't buy you a whole lot, and takes up a lot of space. So for right now, don't do that is my recommendation. And so I told Claude, also, don't do that. Claude would instantly just clone the repo right here in the work directory in every project you work on. And that's just not a great approach. So that's what that comes from. So this is the startup piece, update Claude MD. Now you're ready to be in this, every time you get back to this project, you're ready to run. Now, let's do this. I'm going to copy almost all of this, okay? Because your task here is not informative to Claude. So I'm not going to copy that piece. Now I'm going to take this away again, and I'm going to give this to Claude here, and then I'm going to say, switching your voice. Using smart pins to set up serial transmission at 115/200, please. All right. So I'm telling it how to find the information first, and then I ask my question at the end. And so let's see what it learns how to do. The only connection point it has are those URLs in Claude MD. I built the system so you can download things on demand as you ask questions. Each of these files that it downloads have and impact what's called your conversational history. The different models, Opus and Sonnet, have different conversational history depths to work with. When you use Claude free, you have a certain amount of tokens you can use in a day. When you use a $20 a month plan, you have a certain amount of tokens you can use in a day, and you're going to be throttled to those limits. Then let me okay. So here's what it
Is
just
that a
answered.
24-hour day or a 12-hour day?
I can't say. I'm guessing 12, 24 probably. 24 is probably correct. But the net result is these systems are being used worldwide. And so finding a time when the servers are not busy is entertaining. And for my time zone, they get saturated, I want to say late evening, and I'm in Mountain Time Zone. And so it's kind of interesting. But the point is, and let me show you this while we're thinking about it, and then I'll come back to this description. So here's Opus. This is the one that's used for complex tasks, reaches limits faster. You see that? That's a 10x use rate on token limits. They let you use this model for the first 50% of your tokens, and then you're going to be switched back to Sonnet automatically. Sonnet then is for daily use, and then Opus Plan Mode is just for planning, and then switches to Sonnet otherwise, and it can auto switch between the two. But anyway, Sonnet's really strong in code. Opus is much more strong in natural conversation and documentation writing.
Hey, Stephen,
Yes, go ahead.
did you point out that the limits are really in 5-hour blocks, right?
I don't know that.
That's been my experience.
Okay.
So if you run out, then it's up until the next 5-hour block. But since I've been using their Pro or Max package or whatever it's called, it's the $200 a month one. It's actually, I've never run into any limit with it
Okay.
using either model.
Okay, good. That's exciting. I've been having 3 and 4 instances running side by side, and even at the max that you're using, Chip, I find myself exhausting after 3 or 4 hours of work, and then I have to wait. And so, and this will be true over time. Depending on the quality of work that you're getting, or the rapidity of the work that you're getting, or the advanced development style you're using, you can really burn through credits credits, tokens. I don't know the proper name. Pardon me if I'm not using the right term. It's probably tokens. You can burn through them pretty quickly. There's one thing that you can do with most of these CLI servers now, and that is they have agent support, which means I can provide a context that is very narrowing in capability in terms of something you want it to do. I want you to build only unit tests. I want you to build, you name the small sub aspects of some work that you could be doing, or I want you to update this document from this particular voice or sense of style or training form. And you can have these agents spun off by your top agent, and they all consume these tokens. And so once you start working in a 3 or 4 or 7 agent realm, it can get, token spend can happen quite quickly. When I'm focused on working and I am using this for my own development work, I'm generally a partner with the AI. And so my experience has to come to bear for me to focus its efforts. And so I'm going to work one-on-one with one agent, not multiples, when I'm working. So now we talked a little bit about time limits and conversational history. My experience has shown this. That's why I have this page. 2.5 to 4 hours is about your max window with Claude. Claude Opus and Sonnet. Sonnet can get a little flakier a little earlier than Claude Opus. And when it does get flaky, it's interesting. Meaning the work quality goes down, it's more forgetful, it tends to, every time it makes a change to a file, it adds a new suffix to the file, so you can end up with hundreds of files side by side and things like this. So guiding its work process can be challenging. What do? We have this clear conversation. There is a /clear command, or there is getting out of the CLI and coming back in. No amount of time needed between, just get out and come back in. And both of those will clear the conversation. However, how do you keep going, right? And so how you keep going is you ask things like this. Just before you're going to walk away, all right, you ask it this. And that's why I have this as a copy and paste. You literally say, summarize what we've been doing. Give me a paragraph or so that reminds me of the context. Then when you come back, you say, okay, continuing off, here's your summary that you got, right? You paste that in, and now you can remember and continue on. It's amazing, amazing way to keep work flowing, and you're not starting cold every time. It's not quite cold, but it feels like it. So I put this here to help you. That's an amazing piece. I actually developed some tools around this that I use with my Claude, and we'll see how I'm going to make those available. But there could be some support around this soon. Okay, is there anything else in here? Okay, just for reminders, things you can ask. You can ask pretty much anything. This is open conversation. When we have this structure, let's go back and look at the answer we got now. If I'm moving too fast, please let me know. So we asked it, what do you know about the smart bins? And it says, well, we can configure this, and here's how you set it up. Here's how you configure it. And I don't see the clear chip. I expected to have it in here, and it's not again. But you can see that it's beginning to think in is this even consistent? Yeah, I guess it is. So it's got a reasonable sense about how to work with the pins. I've been actually scraping the documentation for everything on all the smart pin modes, everything in the Silicon doc, everything in the datasheet, everything in the Spin2 language reference manual, everything in the partial PASM manual. And I've been studying this from, are there any conflicts anywhere in the documentation? Rich discovery of what information is available about the P2, what's missing, where could we know more? And so that's my focus in making this available. And so that's what I've been working at. So I've taken you through the quick start, and you have an ability to ask it about anything. Let's see, what can I ask here? . Well, do you have any questions? what
Hey,
can I- Yes,
I
go ahead.
asked it the other day, could you make a smart pin generate a signal that's low for 2 clocks, high for 3 clocks, and repeats? And it
Mhm.
actually made code that worked, but because of some ambiguity in the documentation, it made the signal came out inverted, which was no big deal, but it got the right, it picked a mode and it wrote code and the code ran. Then I showed it the Verilog code for the smart pins, and then it was able to clarify its thinking a bit, and it wrote perfect code then.
Interesting. Interesting. So we need to identify where that information is missing from the documentation and add that. And as soon as we tell it that, this will shape up, which is wonderful. This is something we should talk about is as we're working this, I'm going to be chasing as deeply as I can through the documentation. And it's a bit of an effort, of course, but I have lots of clods to help me. And we're verifying accuracy as well.
Is the Claude a bit more accurate than ChatGPT?
I don't have a way to contrast that.
My experience has been that Chat GPT maybe knows more about more things. And so it's useful in that way. But Claude is pretty good. But where Claude really shines, I downloaded the command line interface. You can have it look at your file through VS Code, and you can ask it questions like, are there any routines in here that aren't being used? You could even ask, is there anything wrong with this code? Does it look like anything's wrong? And it'll come up with some pretty interesting critique on code. It's pretty insightful. You can also have it, pretty up your code, like put comments on a certain column. It can just do that. There's a lot of stuff that's very easy. So there's really no trick to using it. Once you load it, you just it's all conversational, and it has access to your working directory that you're in, and it can just open files, work on stuff. You can teach it how to, I have it running Peanut, and then it looks at the debug output, and it can run tests iteratively that way, where it homes in on solutions by modifying the code with debug statements, seeing where it got, what values it had, and then going back, modifying the code, rerunning it, and working in a loop like this. And it's been pretty effective. But I will say this, the P2 is kind of an obscure chip in the world. I think it knows a lot about the Arduino and can write perfect Arduino code, at first bat, but it has a lot of knowledge. And so like here, we're trying to implement right now a Ethernet IP system. And I haven't known anything about Ethernet or the CIP protocol or any of this business, but it's kind of gotten us into the ballpark. And then it wrote good, sensible code, but it wasn't always exactly what was needed. So I've had to I look at what it wrote and I can see its framework is correct, but some of the details might be wrong. So it's kind of like an assistant that can do a lot of busy work for you really quick and get you in the general space you need to be in, but it's going to take some, watching and getting more involved to get to a final, finished piece of code.
One of the things I did to the database is I took all the data sheets for the eval boards, and I took all the data sheets for the add-on boards and for the prop plug and things like this. And so I was able to have it internalize that information. And then, what are you doing now? Thank you.
Oh, it's running the compiler.
Yeah, it actually It's running my compiler and proving that the code works. You can see that I gave it access to the compiler. It studied the command line for the compiler because I have built-in help. Same thing for load P2. And it studied the commands for that. And now it's able to use them and talk to my hardware directly. I won't demo that today because I've got a better demo coming up in a bit. It has this capability. So you can have it build and test code that it writes. Just to show you what it's done using, of course, my favorite tools. Why would I use otherwise? Yeah, let's take a look at this one. This is the code it generated. And you can see it's reasonably accurate in how it's generating spin2 code at this point. It does tend to like to document what it's doing in a reasonable way. It's not overly verbose in comments. And it's using elements of the language that you might expect to be used. What's with my, it's just ending there at the end of the file. I'm not used to having nothing at the bottom like a copyright notice or something. So that's what we're capable of generating today with the knowledge that it has. Remember that from the P2, this is just downloading information from my repository. I pointed it at the repository. I asked it questions. It's thinking about it and doing it. And so it's doing the additional research to download additional pieces and to help us out with what it's trying to answer. So it's not doing a terrible job right from the start. I would have loved to have a more complete demo where I'm round tripping with the entire hardware, but that's coming. So not yet today. How long have we been going? We've been going for about 40 minutes. Do we have any other further questions or observations? Have I? Yeah, go ahead.
Yeah, stupid question. I went up here to download this stuff. You just download it, and then I got an exe file and run it, and then go from there and see what happens, or blow up my computer.
Well, yeah, that's always a risk, isn't it?
I think you need Win 11, right?
Yeah, I'm running Win 11. Yes.
Okay, so this is Claude code that you're downloading. Chip, you have experience with this.
It says meet Claude on your desktop, Windows. Gave me something to download. It's from Claude.ai download.
Does that sound right, Chip?
I can't really remember, but yeah, I guess it does.
Yeah, because it says Claude, and it's got an orange snowflake on it, like thing.
Yeah, yeah.
Yeah, okay. I'll run it and see what happens. Okay. All right, you guys are I'm sorry, Stephen, you said you weren't gonna be long. You're gonna be done shortly because I'm gonna run.
I think I don't have much else for this presentation. It's open to questions. I wanted to introduce the fact that this is available and available to use. It's going to be getting better every time I find more information or as I do another post-processing pass in the information. It's pretty rich right now. You saw how I can generate documents out of this. You can probably expect that I'll be doing some documentation that the community asks for or wants or needs, right? We'll try and create things that are missing. But we're going to create them in a way that they can be approved and certified and released as official documentation. Any other thoughts? Shannon, is this starting to look interesting to you? Is it something you use? Have you tried?
I think you and me and Chip here spent a year and a half ago sometime doing this. I have not stopped since.
Okay.
I'm on Perplexity and Grok. I go back and forth. I've got crude documentation that I just pulled down in Markdown, and I dump that into my context each time. Does reasonably well. There's a few things in Spin 2 it keeps hanging up on. I've got some quite lengthy files I've been working with, but sort of as you saw, you find after a few hours with one or one context, one thread, it'll kind of go off the rails. And I do use that regularly, sort of a summarize where we are sort of thing, and then well, take that from Perplexity and dump it on Grok. And and sometimes, well, I'll often start a project giving them both the same prompt, and they come up with different solutions often, or different, I'll like some aspects of one and some aspects of the other, and I'll stitch them together and then bounce them back and forth. But yeah, I have the best luck if I do a test first coding. I'll kind of have them give me an outline. I'll give them a little outline. They'll give me a more full outline, and I'll pick and choose from that, and then bounce it back to them, and let's write the test first. And you can keep on a pretty measured forward progress with that approach. Every now and then I'll do it'll get over anxious or zealous or whatever, and Bing dump out a bunch and say, wow, that's pretty functional already. And I've got to resist not going with that. Because there'll be some aspect that's not right, and once maybe I wouldn't have recognized it until I bumble down and say, yeah, that's not a good architecture, not a good solution for that.
So true.
But I commit, because yes, sometimes it'll sweep through and just do some tidying up for me. And I said, no, I didn't ask for that. And it's borked something else that I've got to, I can catch easily with a diff and a diff and a diff. Well, you wouldn't think you'd diff every little thing, but it's effortless, and really helps when it gets, just doing a little extra. And that's a problem.
There's an eagerness that I find to the models, where it'll see something and all of a sudden it's, oh, you need this, this, and this too, and that's really And so one of the things I've learned, and you saw when I showed you the models, there's a planning form of Opus. Opus is for planning.
Yeah,
this is a much stronger language model.
Yeah.
And so what I will do when I'm doing work sessions is I will enter planning mode. We will describe everything about what I want built.
Yeah.
Everything. We'll sit there and I will describe it. And then I say, do you have any questions? It'll ask me questions about the plan. And then once that's exhausted, then I say, well, what about these edge cases? What are you going to do about these edge cases? And we end up like a page and a half or 2 pages of description of plan. All right. Yeah. At that point, I say, we're both agreed, none of us have questions. Here's what we're going to execute, what you're going to build. And it says, yes. I say, okay, good. Now, here's what you're going to do. You're going to write paragraph length to-dos. You're going to be explicit about what the work is, and you're going to be explicit about which files you're modifying and things like this, or if you're creating new ones. And then I said, if I'm working in an existing code base, you're going to look for refactoring opportunities to split out code that could be reused. And you're going to be looking for using code that already is split out to be shared. Look for reuse opportunities in the new pieces you're writing. Now write that task list. And then and it generates the task list. And then I say, okay, fine, let's review the task list. Now, how do you order that? So there's no rework based on something you did earlier, right? How do you build foundation pieces first? Where do you put the testing? Where do you put the test writing? And we work out this entire task list. Once that's all done, both those phases, I can turn it loose and I'm at a 90% solution every time.
Uh-huh.
It's pretty, but it's
The
explicit.
the 20%, I do the $20 a month on Perplexity and Grok, and Grok has a think harder, but Perplexity has
A pro or something?
yeah, it's pro. It's not, yeah, just the $20. I think there's a higher level, but this is really works well for me. And anyway, it has a planning mode,
Okay.
and it likes to, let's just work in natural language here. Don't get off into code, right? And do that planning process. And I will commit those documents. It'll generate, and you can export in Markdown, and I drop it in my fossil repositories, which are easy to view. And I remind myself, where were we going with this?
Yeah. With
And
it.
yeah, we work out back and forth. I really use it like somebody sitting there and bounce questions off, and then I'll think I'll have it, what I'm trying to get to, and yeah, ask it to, how would you prompt yourself to get better results out?
That's actually so very true. One of the issues we have with Opus being the larger language model and Sonnet being smaller is that Sonnet is much more enthusiastic and wants to get right to it and will wander off the rails much quicker.
Yeah.
So it's not uncommon to use Sonnet to generate Opus to generate the description of the work for Sonnet. So it's a good complete work description, and then have Sonnet go ahead and do the work, and it doesn't run off the rails as much, which is quite nice. The other thing I find is if I want Sonnet to be doing some work in a code base where it's fundamentally a working code base, and I want it to make some point change, I've got to remind it, this is working code. Don't go flunking in the code. Don't change other things. This is working code. Focus on this very narrowly. And secondly, if I can describe the nature of the change I want versus having it figure out the nature of the change, it's going to be much more accurate in making the changes. And so this is a case where my skill set in terms of how I would make the code or think about the problem technically, or how to do in higher speed serial buffering or something with other ramifications I don't have to consider, so rule it out of the algorithm. As soon as I narrow the work like that, I find that I'm getting much better code generation results.
Yeah, I'll use it. Sometimes I'll go into something I don't know what the patterns are, and I'll just open-ended let it describe. Ask, how would you solve this, and not launch straight into code necessarily. Again, with both of these extra, I guess Perplexity calls it research or something like that mode.
The deeper mode. Okay.
It will, yeah, you give it more an open-ended question, and I learn a lot if I don't even know the approach to take sometimes going in. But I'll type it in and it'll say, yeah, give me 10 minutes. And it'll go off and churn, do multiple queries. It'll come back, it'll learn something. It says what it's learned and fire off some new queries and pull up more stuff. So sometimes there's a few rounds of that before I decide what seems like the best approach.
Hey guys, I got to take off. Thank you very much, Stephen, for your presentation. I really enjoyed it. Nice to see everybody, and y'all have a good one, and I'll play with this. It's scary. It said, I told it thank you. It said, you're very welcome. That's scary.
I know. It is.
Hey, I have here Austin with me. He works at Delco, and he was using was it just Chat GPT?
Yeah.
Oh, so okay, he's gonna explain to you an experience he had over the weekend. It was kind of interesting.
Okay.
Yeah. So I've kind of actually, based on Chip's recommendation, talking about asking it questions about just implementing things into programs and things like that. Well, I got to thinking, I do a lot of ESP32 and Arduino style programming just for small little RC cars and little home projects like that.
Sure.
And I started proposing some just crazy scenarios to Chat GPT to the point of I would tell it just, I'm using this type of LED, RGB LEDs, certain strips, inputs from PWM signals from like radio receivers for RC cars. So it'd pull in that. And I would just start proposing these crazy questions. I would say, okay, well, I want this type of LCD to say this. I want 4 different strips of LEDs, and I want LEDs to trigger based on this input and this. I literally proposed it a whole paragraph over the weekend, and it spit me out 350 lines of code, and everything worked first try. The only thing I had to do was things that I forgot, like tell it, oh, well, let's hook the LEDs up to this pin and whatever. And it would just go change it all and implement it all. It was crazy. It blew my mind.
So yeah, so the deal with that is that these models, these AI models have had a lot of training on very common stuff like
Very common, yeah.
Arduinos and ESP32. So their confidence, well, the confidence of the AI always seems very high, but I'd say their competency is actually very high.
Yeah, it would even give me wiring diagrams. It would tell me, it would hold my hand. It would say, you can't use this pin because this is an input only pin. Use this pin. And I was like, oh, okay. It'll correct me in everything I tell it. Even if I
Yeah.
tell it where I want things, it tells me do this instead, which is crazy.
Does it
Yeah.
tell you, I'll be back?
Does it tell me what?
I'll be back.
No, not yet.
Bye,
Worst
guys.
case scenario, it says, I'm thinking.
See you guys. That was cool.
Later.
Right.
Anyway, we want to get to like that level of competency with the P2, which would allow a lot of people to do things they cannot do with an Arduino.
Yeah.
Mhm.
Freaking cool. But, cool. All
Well,
right.
thanks for telling
Yeah,
us.
Thank you.
I'm interested that
I'll come like you
the
a lot.
way you coached the way you coached Claude and gave it a very specific list of things and guided it. You know, don't generate code until we have this nailed down. And every time you kept talking, it kept getting more and more refined. I thought, wow, he's almost written the whole code here. But I think that the prompting of chatbots it's a whole new skill that we have to develop, and I appreciated
It
your
is.
detail to which you explained that. And I just wondered, are you able in Claude to capture your interaction? The company I work for has a sandbox chatbot, and I'm able to print to PDF through my web browser my interactions with it in case I want to go back and look at it. And I think that for most of us starting out, it might be advantageous if folks could if folks could look at your prompting or an example prompting to see that interaction.
Yeah, that would be good because it is very common sense level. There's no secret to using this. You just talk to it. You say, well, I've got this executable here, and you can form your command line this way, and you can run the code, and you can check the debug.log file afterwards, and it just starts then, you know, you give it incremental permissions, and you can say, okay, I permit you to do this without asking every single time in the future. And you can actually get it into a loop where it's modifying code, you know, compiling it, running it, looking at the output, making changes, and kind of homing in on the solution.
I forgot that I'm probably on a live screen here, aren't I? I was just, you're asking me what I ask it. So it's a crazy collection of things that I'm doing, depending on what kind of project I'm working on. So it can be detailed. It can be all sorts of type of stuff. No, I don't have automatic collection of that. And that'd be an interesting thing. I wonder if we could somehow wire up Claude to do that. What I do is when I'm regression testing, I've made changes to an app, and I'm now regression testing, where I'm now acceptance testing of the new features. It's common for me to have two Claudes, one building the features and another one running the testing. And what I've done is I've used a Claude to extrapolate the interface, the tests that we're going to be doing, and the behaviors at each of the APIs. And then I'll have another Claude exercise those APIs and look for expected results. And I won't let the two see each other. I want pure testing, and I run from the ground up. I want you to run this exact same scenario every time, verify the results every time. And it's like a 29 API environment that it's testing. And it'll find things wrong. And I'll pass the entire, I'll say, run the test, annotate all your findings, and record that result. And then I take the annotated findings report over to the other Claude and say, okay, here's what's wrong, go fix it. And in my worst cases, it's taken me 9 iterations. And in some of the most sweeping changes I've done, it's only taken me 2 or 3 iterations of that kind of testing. And so that's one of the techniques I'll use when I'm generating something that's externally testable. In the case of generating P2 applications, I'm actually, I'm actually doing not P2, I'm actually doing a terminal replacement that I'm hoping to release within the next couple of weeks. Think a PST, but think you've got the full debugger window support in it and the single step debugger on multi-platform. And so now you've got the ability to download to your device and hear all the debug stuff coming back and display all the windows. So I'm building that out. And so it's common for me to have the Claude that's helping me build the app and me doing testing, copying and pasting from my test results, logs and things, console logs and debugger logs. And then I'll paste that back into the Claude that's working on the code. It'll study all that output, identify what's wrong and things like this. And then it'll work on the fixes and propose fixes to it. And so iteration cycles like this really help. But in that case, in that essence, I have to be a little bit more guiding because it can decide on some pretty fancy solutions where I don't need fancy, I need functional. And so,
I do some similar debugging strategy. Well, yeah, I played a little bit with the gee whizzy graphical debugger. And yeah, step through and see where things are going. Is that what you meant? And stuff like that. But kind of these opens up just plain old printf debugging in a way that didn't make sense before. And I would take something that gotten long and hairy perhaps, or has multiple cogs going. That's really useful on multiple cogs. But I will say, I'll just dump it on there and say, printf, print statements, debug statements all the way through, and it will just obscenely load up every step of the way. Every decision has a debug on it. And I'll run it, generate that, and there's 4,000 lines of debug statements. And I will give that, well, to another window or another engine and say, walk through this, look at the code, walk through this, and where's it gone wrong? And it's huge. And then you can go, you've got everything committed, and you can go and say, okay, strip out the debug statements.
Mhm.
and away you go.
Yes.
That's saved me a few times.
This is the technique that's built into the PNet term that I'm building. Is it automatically captures the logs from the DTR reset to the next time you reset to files and timestamps. And so if you're using the standard debug to compile your application, and now you can literally suck these logs into the Claude environment and have it figure out what's going on. And so this is working very well. I don't know if you know, but the Flash environment, the FS Flash that we did,
Yeah.
that is entirely regression tested using these logs. And so it is. We checked out and certified every single feature of that thing. And then we used the logs to audit the results, and we didn't release it until the logs were correct. And so having this automation to review the logs now and understand what areas are breaking because of the failures is huge. It's going to make life so much easier for those of us that are doing regression tested environments and developing new algorithms. While I was doing the BLDC work, we spit out a lot of logs. And there are people who have seen my BLDC work and go, I don't know what these logs mean. And I go, well, I'm sorry. I didn't really intend them to be understood, but they're there. And so I can help you understand. And so, yeah, logging has been essential in my life. And printf has been the dominant form for the very reason that it was ubiquitous on all the platforms, no matter what we were working with. Any other people doing this stuff, having fun with it, running into problems? What are your experiences? Otherwise, we should probably call it a day. We've had a good session today, and we'll see everybody tomorrow for the live forum, I'm guessing, and talk
I got a
about.
question.
Sure, go ahead.
When you start off a Claude session, do you feed it like propeller documentation to do reg on that docs?
Not any. No, the conversations are too small. You couldn't do that. That's why I built the system that I showed here today. The conversational context is way too small to suffer all the documentation. And so I built this download on demand system. Did you get the URL okay for the repo?
I did not.
Okay.
I'm guessing it's in chat somewhere.
Yes, I'll just point you to the quick start right away in chat also. And so what you want to do is hook this up to Claude the way we suggest. And now you don't have to ingest the documentation because it will know how to answer your questions by going out there and looking. And so this allows you to have all of the P2 documentation in hand, so to speak, and we're constantly making this stronger.
That is cool. I gotta look at how to do that on a local level. Like Llama 4 has got some pretty good context window, like 1 million, I think, for
Right.
mega tokens for Llama 4 Scout. I'm not sure about Maverick, but
and so yeah, you can. It's built so that you can see how the system is there. It's a repo if you want to clone it, to create a local copy. There's a whole bunch of extra stuff in there you don't need, but the net result is the knowledge base itself is one subtree, and there's a manifest folder that points to that subtree in different ways.
very cool.
And so those are the two key things. The point of this system is that no matter which CCLI you're using, Claude CLI or other CLIs, is that you can point them to this system and they can still use it. Now, in the end, Claude has something that's known as an MCP. which are extensions that it can use to reduce its network traffic. And so we can actually create an MCP that you would put on your host system that would require less network traffic with this repo to answer questions. And so we'll be looking at that as well. Should the community decide it's useful enough that we want to develop that. The prototype's already up there in the repo.
That's pretty neat. It's exciting stuff. I appreciate your leading this, because it's opens up a lot of possibilities for us that aren't as good at programming.
Yes, well, it came from, and thank you. It came from the fact that my son is in this business, has been studying AIs and interacting with them for a long time. And he's been pushing on me for years. And I've been pushing back because it's AI. And finally he showed me, well, here's a case where I'm using it for code. And I said, what do you mean you're using it for code? My son has always looked at my career. Since 72, I've been writing code. 20 years with Hewlett Packard. My son has looked at my career, saw the downsizing that happened there and all the terrible workplace environments I've had to live through in my career, and decided he would never be in software. Then he comes to me this past year, having written from the ground up, quote unquote written, an iOS application, Apple Watch application tied together that interact with these systems that is doing an amazing function. But he came to me after me having been an iOS developer. Both of us went through iOS courses in college together. I sat in his courses in 2009. I've been developing for iOS since 2011. He came to me and showed me an iOS app that he built that was stunning. Fully capable, fully Apple Watch, fully iOS. And I said, how in the world do you do that? He showed me Claude Code. So that's what got me started. And so I said, basically, if you can find it to have you learn how to do that and teach you how to do that and run Xcode and run develop in Swift to do all of that, then for sure, I've got to understand what you're doing. And so he came over, set me up, and within the first week, I had things running in terms of looking at my own code bases. Within the second week, I had come up with this idea of how we're going to actually make it work for the P2. And so, as luck would have it, when I started that, they scheduled this AI meeting out far enough that I could just make it with as much as I've shown you now. So I was lucky. Because I had a thought I could make it happen. Even Chip will tell you, I told him I couldn't do it when we first started. And then I came back to him days later. I think I might have found a way. So we're making some progress.
Well, yeah, Steven spent a lot of years managing engineering teams, so he's kind of taken that approach, I think, to managing AI. So it does kind of require a
Things that
different
I
skill set, but
think
you
I
got to
can
know how to
do.
program to get it to do.
Don't forget to ask AI. It'll give you some ideas, and well, it may just encourage you down a path of something you can't do, actually. But I don't know. It's done things, got me into things that I didn't think I could do, and I forget sometimes I've got that pair programmer not just for code, but lots of other, just architecture things or electronics and getting into. I'm redoing the electronics in an MGB 1980 right now. Pulling all the old wiring out, putting a
That's
CAN bus
electrics,
in
not
it.
electronics.
And yeah, I mean the smoke was all let out of it already, so I couldn't do worse.
Yeah. I personally drove the two different MGs. When I was over in England for 2 years, I bought my first car over there. It was an MG. So I understand. Good, fun cars.
Except for the electronics. I've heard the electronics in British cars are these horrible.
Yeah.
But Chrysler cars are horrible too. I mean, they got the worst electronics I've ever experienced.
Nope, I didn't have any problems with the car, thank goodness. Young military guy driving around an MG. Would get off shift work at 8 a.m. in the morning and drive down to London for McDonald's, 80 miles away, just for fun.
Just for fun.
Just for fun.
I got the Quen 3 Coder 480B up and running recently on my 512 gigabyte server, and it runs at like a token and a half per second, which to me is, if I'm gonna just like develop a prompt like Stephen was talking about, I can just let it work on it. I mean, I don't need to watch every word come out, right? But it knows P2. And so I'm impressed, but it's still, from my experience, if you go for C and C++ code, I mean, the results are so much better. But then you don't, at one point you got to dig into the hard P2 documentation to do the all the special features like the pins and stuff. But I've been throwing some simple stuff at it lately, and it well, I haven't had a P2 hooked up for a couple months now, so I gotta get that set up, and I gotta set up I got too much mess here. I gotta clean up to make space so I can start interacting with a real P2, and we'll have to look at what Stephen put in this document so I can basically feed my local models the same kind of stuff if it can handle it. I know Llama 4 can handle it because the contexts are huge, but I want to do most of this stuff locally.
Okay, it's time for us to shut down. I think Chip, you said you have to go too, so let's see everybody tomorrow. And thank you for attending today, and thank you everyone for offering your experiences with things. This has been helpful.
Thank you, Stephen. Thank you.
Okay.
Very well.
Thanks.
All right. Thanks, guys.